The YF-12 stands as one of the most extraordinary interceptor prototypes ever created by the United States, a remarkable machine born from the same high-speed lineage that produced the legendary State Route 71 Blackbird. Developed by the Lockheed Skunk Works under the leadership of Clarence Kelly Johnson, the aircraft was originally conceived as a high-altitude, long-range interceptor capable of defending the United States against advanced Soviet bombers during the Cold War. Although it never entered mass production, the YF-12 became an essential breakthrough for American aeronautical engineering, providing vital research that shaped both the State Route 71 and later high-speed aircraft development. The YF-12 was built on the same basic airframe and aerodynamic design as the A-12 reconnaissance aircraft, the predecessor to the State Route 71. However, unlike the unarmed A-12 and the surveillance-focused SR-71, the YF-12 was designed for a pure combat role. It carried advanced radar systems, powerful weapons, and specialized flight controls intended to allow the aircraft to intercept and destroy hostile targets at extreme altitudes and unprecedented speeds. The concept was simple in theory but exceptionally challenging in execution: an interceptor that could fly above Mach 3, detect threats far away, launch long-range missiles, and swiftly exit hostile zones before enemy defenses could respond. One of the most distinctive aspects of the YF-12 was its incorporation of the AN/ASG-18 radar system, which at the time was the most powerful radar ever fitted to a fighter aircraft. This radar allowed the YF-12 to detect and track targets at ranges far beyond the reach of typical interceptors of the era. Coupled with the radar was a sophisticated fire control system designed to guide the aircraft's primary weapon, the AIM-47 Falcon missile. This missile was engineered for high-speed engagements, capable of tracking and striking targets such as bombers or reconnaissance aircraft flying at altitudes above 80,000 feet. The combination of radar and missile created an offensive capability unmatched during the 1960s. The aircraft's engines were another defining feature. Powered by two Pratt & Whitney J58 afterburning turbojet engines, the YF-12 could sustain speeds over Mach 3 for extended periods. These same engines would later become famous as the heart of the State Route 71. The engines were uniquely engineered with a hybrid turbojet and ramjet airflow system, enabling efficient high-speed operation while maintaining stability across a wide range of altitudes. Managing these engines, however, required advanced operational techniques. Pilots had to monitor temperature limits, intake pressure, airflow shockwaves, and a host of other variables to prevent compressor stalls or engine surges, especially when pushing the aircraft to the edge of its performance envelope. Like the SR-71, the YF-12 was constructed from titanium alloy to withstand the intense friction-generated heat at high speeds. Flying at Mach 3 caused the aircraft's skin to heat up to more than 600 degrees Fahrenheit, leading designers to reimagine traditional construction methods. The YF-12 used loose-fitting panels that expanded during flight, specialized paint for heat resistance, and a fuel system that doubled as a coolant to maintain internal temperatures. Even the fuel itself, JP7, was developed specifically for high-speed aircraft and was difficult to ignite under normal conditions, requiring a special chemical called triethylborane to start the engines. In terms of flight characteristics, the YF-12 was designed for stability at extreme altitudes and speeds. Its long, sleek fuselage, sharply swept wings, and chines along the nose provided excellent aerodynamic efficiency. Pilots described the aircraft as powerful and responsive, though demanding and unforgiving. It required precision during takeoff, careful management at mid-altitude, and expert handling during high-speed operations. Landing the aircraft also required long runways and precise aerobraking due to its velocity and weight. Despite its impressive capabilities and successful test flights, the YF-12 program faced political and strategic challenges. At the time, the United States defense focus shifted toward intercontinental ballistic missiles and reconnaissance platforms. Funding for high-speed interceptor programs became difficult to justify. Only 3 YF-12 prototypes were built, and although they set several world speed and altitude records, they never entered mass production. The Air Force eventually canceled plans for the production F-12B variant. However, the YF-12 program lived on through its contribution to research. NASA used the aircraft extensively to study high-speed flight, thermal dynamics, aerodynamics, and propulsion performance. Many of these studies directly impacted future technologies in aerospace and laid the foundation for strategic reconnaissance platforms. The program helped refine the aerodynamic design that made the State Route 71 an icon and influenced later experimental aircraft and missile systems. Today, The YF-12 is remembered as an engineering marvel that arrived at the intersection of innovation and shifting military priorities. It showcased what was technologically possible during an era of rapid advancement and extreme secrecy. The aircraft continues to capture the imagination of aviation enthusiasts, historians, and engineers because it represents the ambitious mindset of the Cold War in the relentless pursuit of speed and altitude excellence. With its combination of stealth-shaping beginnings, powerful radar, high-speed intercept weapons, and groundbreaking propulsion technology, the YF-12 remains one of the most extraordinary interceptor concepts ever conceived by the United States.